Alright, so let's work out some problems to see how transformations work on exponential functions. So here we go. The first question, again, you may want to pause a few seconds and think about how you can tackle this problem. So part 1 here, determine the transformation required to obtain the new function, and then second part, describe any changes on the domain, range, asymptotes, and intercepts. Alright, so if you look at this one here, I would once again write down, in this case, the general formula for the transformation of an exponential function. A times B, that's the base, and then this base is horizontal stretch, x minus h, and then plus k. Okay, so now if you compare these two exponential functions here, I hope you can see that there is a vertical stretch by a factor of 2. Look at this. So first thing is vertical stretch by a factor of 2 above the x-axis. Okay, that's one thing. And next, so if you compare the general form of the transformation of an exponential function to this, you see that there is a horizontal translation of 4 units to the right. Remember, we flip the sign. So negative 4 here means positive 4 units to the right. So horizontal translation to the right by 4 units. Alright? And of course, if it is a diploma exam question, you can cheat a little bit by plotting this and this on your graphing calculator and then see the differences visually, okay? Or at least to compare as a double check for what we have figured out here. And of course, I hope you can simply do this question without using a graphing calculator. Anyway, so let's set up a table here to describe all these changes. So let's talk about this one here. Y equals to 3 raised to the power of x, and then the other, oops, y equals to 3 raised to the power of x, and then another one is the new one, y equals to 2 times 3 raised to the power of x minus 4. So now let's look at one thing at a time. First thing, let's look at the domain. Alright, so if you graph this on your graphing calculator for this function, have a look on your graphing calculator, you will see that axial, the domain or the x values includes any real numbers. Same thing here for the new function. Again, graph this and see it yourself. Okay, one thing done. Next thing, let's look at the range. So if you look at this graph again, you will find that the starting part of the graph looks very close, or may be thinking that it's actually touching the x-axis, and once again there is an invisible line, the untouchable line, that we call the horizontal asymptote. So in this case, y has to be greater than 0, not even greater than or equal to. Nope. Alright. So because the thing is, there's no x-intercept. If y is equal to 0, there's an equal part here. That means you will have an x-intercept or touching the x-axis, which is never be the case. So with that said, you would expect the same thing here. Because there's no vertical translation, so the graph would only be stretched vertically and horizontal translation. No vertical translation. Alright. Next, let's look at the asymptotes. So as I mentioned, for this part here, when we talk about the range, so there is an untouchable line, so you find that the graph looks almost touching the x-axis, but it's not the case. So you have a horizontal asymptote of y equals to 0. Okay, nothing touches 0, nothing goes below 0. So same thing here. Again, look at the graph on your graphing calculator. And because of what we just talked about for the horizontal asymptote and the range, so that means in this case, since the graph would never be touching or crossing the x-axis, so therefore you have no x-intercept. So in this case, for this graph here, there would be none, and same thing here, there would be none. And the last thing we are going to look at is the y-intercept. So if you look at this, I hope you still remember this from last time, or simply look at the formula sheet. This one here, ABX. So if you look at this, I'll just write it down here. Y equals to ABX. If you have an exponential function written in this form, compare this. This is B, this is the exponent X. So the invisible number in front for A is 1. So that means our y-intercept is 1. Alright, just look at the example from last day. So y-intercept is 0 and 1. So this is something you should be able to figure out without even graphing it on your graphing calculator. But again, if you're not sure, or if you want to double check your work, so you can still graph this. So use the special feature on your graphing calculator, look for the y-intercept. And then this one, you tend to think that in this case the y-intercept would be 2. Nope, it is not the case. Why? Because it is not written in this form. Yes, this may be in your quotation mark A, but if you look at this, the base is 3 here for B. But then if you look at our exponent, there has been some horizontal translation, so therefore you cannot simply eyeball it and say, oh, my A is 2, so my y-intercept is 0 and 2. Nope, you don't do it this way. Okay, so again, you can either do it by looking at the special feature on your graphing calculator to find the y-intercept of this one, or let's quickly do the math here. Alright, so for the y-intercept, if you look at this here, so for this one, so y-intercept means when x is 0. When x is 0, so you plug that in, y equals to 2 times 3 raised to the power of 0 minus 4. Okay, so 2 times, in this case, 3 raised to the power of negative 4, which is the same as 2 times 1 over, if you want it, this is the same as 1 over 3 raised to the power of 4. Okay, so that means this is the same as 1 over 81. If you are still not sure how it works out, by flipping this 1 over 3, you can get rid of the negative exponent. Okay, so that gives you y equals to 2 over 81. So as predicted, you cannot, because this is not in the exact form like this. If it is just x without the minus 4, then your y-intercept would be 2, but in this case, no. So that means in this case, your y-intercept has a 0 and 2 over 81. 0, 2 over 81. Alright guys, let's keep going. Now let's look at question B, and before we start on question B, once again, let's write down the general formula for the transformation of an exponential function, which is y equals a times b raised to the power of b. This b is the horizontal stretches, x minus h, and then plus k. So if you look at this one here, I hope you guys realize that this formula is not on the formula sheet, the general form of the transformation of an exponential function. So make sure you try to remember it, learn it, and perhaps memorize it. Alright, so now let's work this out. If you look at this one here, once again, you can cheat a little bit by graphing this, then you can figure out all the changes. But again, I hope this is your last resort so that you can check for your understanding, at least for now. So pause for a few seconds and then see by comparing this to this and look at this general formula. Hope you can figure out what are the changes. So if you look at this, so that's A, that's B, that's H, and this is K. Except that some of you, for those of you who pay attention, will probably realize that this is not quite the form that I mentioned before. If you look at this, I mentioned it a million times, that actually a trillion times, that we want the x to be 1. So how can we make x out of 1? By factoring whatever number in front of x out. Alright, so if you look at this, if you rewrite this, y is equal to negative 3 times 1/2 and then factor out the negative 2. So negative 2 times x minus 2, and then minus 5 here. So in this case, as you can see, we have factored out the negative 2, so now I have x to be 1, and then your horizontal translation would be more obvious. Same for you. Well, this would be, I'm sure you all can figure out that b is negative 2 in this case. Okay, so now if you compare the general form of a transform function for an exponential function to the given function here, you can see that a has a negative value. What does that mean? Negative means it is vertical refraction, so that means upside down over the x-axis. That's the first thing. Second thing, if you compare this, so that means that A is 3. A is actually -3, but then it has two meanings here. Negative means, as we just mentioned, vertical refraction, and then 3, that means it is a vertical stretch by a factor of 3. So vertical stretch by a factor of 3. Alright, now let's keep going. If you compare these two here, so that means our base is 1/2, but it doesn't affect our transformation here. So let's look at another B. This B is the horizontal stretch. Not just that, you have a negative in front. So what does that mean? That means it is a horizontal refraction over y-axis. And again, anything related to horizontal stuff is here in the function. Anything related to the y stuff, the vertical stuff, they are outside the function, outside of this, either front or at the back here. Alright, so the 2 means the B is 2. But remember, when we talk about the horizontal stretch factor, we flip that, so that means we have a horizontal stretch by a factor of 1/2. So horizontal stretch by a factor of 2. Let's just write it down here. Oh, sorry, I mean 1/2, because we flip the 2, so that means it is getting narrower, right? What else can you see? In this case, if you compare this and this, that means so H is 2, positive 2, that means there is a horizontal translation. Horizontal translation. And because it is positive 2, that means it is to the right hand side, or if you flip this, that means it is also right hand side, to the right by 2 units. Remember, anything related to horizontal stuff, x related, is nasty. You flip that, you flip the sign, or you flip the number. Okay, last thing is, if you look at this, obviously that means k is -5, and k represents vertical translation. Vertical translation. In this case, the number is negative, so that means it's going down by 5 units. So if you want to double check your work, you are welcome to plug these two equations into your graphing calculator, and you should see all these changes. So hopefully you figured out all this because you know the stuff without using the graphing calculator. So now let's set up the table here. For the two functions, y equals to 1/2 raised to the power of x. That's one. And then the other one, sorry, I'm running out of space. So that's y equals to -3 times 1/2 raised to the power of -2 x. Okay, so let's move all this here and then erase some of this. Alright, so y equals -3 times 1/2 raised to the power of -2 times x minus 2 minus -5. Okay, so now let's look at each one separately. So next thing we want to talk about is the domain. Let me change the color. Domain. If you look at your graph, again, you'll find that the domain is axial. It goes all the way from -infinity to +infinity across. Okay, and then next thing is the range. So if you look at your graph, so this one is in the standard form. What do I mean the standard form? Y equals to ABX. So in this case, you can simply look at the invisible number in front. So in this case, your b, the base is 1/2, your exponent is x, so the invisible number is 1. Okay, so y is greater than 0. So, and if you look at your graph here for this one here, the range is y is less than -5. Okay, and then for the asymptote, so this is the normal graph. So just like the last example, y is equal to 0 because that's an invisible line. So if you look at this function here, this exponential function, I hope you can see that the graph would never touch and cross -5. So you have an invisible line here at -5. And then for x-intercept, so there is none and there is none again. Sorry guys, I know it's a bit messy. So for the y-intercept, so again, as I mentioned a little while ago, that the invisible number is 1 here. So therefore, and also it is in the standard form, so therefore the y-intercept would be just 1. Here, if you look at this one, once again, you cannot look at this and say, oh, this is the A value. Well, because there has been some transformations, so therefore we cannot look at this number and figure out the y-intercept by eyeballing. So what do? We plug the numbers into this equation so that we can figure out the y-intercept. So if you look at this one here, let's use this color. So y equals to -3 times 1/2. So in this case, x is 0. Let's go back up here. -2 times 0 minus 2, negative 2 times 0 minus 2, because you substitute 0 for x, trying to find y, the y-intercept, and then minus 5 here. Okay, so you keep going, negative 3, and then if you do this, so negative 0 minus 2 gives you negative 2 times negative 2 gives you positive 4, and then minus 5. So you might want to use the fraction function on your graphing calculator. So negative 3, or that means 1/2 times 1/2 times 1/2 times 1/2, which gives you 1/16, and then minus 5. If you keep going, these two gives you negative 3 over 16 minus 5, and this time you may want to use your fraction function on your calculator again, so that gives you negative 83 over 16. As I said, because this is not in the standard form, so don't eyeball it by seeing the y-intercept is negative 3. No, you screw up big time. Okay, so now if you look at this one here, we have 0 and negative 83 over 16. Alright,